Were you guys able to hear me?
Yeah, Shaina, we are able to hear you.
All right.
Yes,
All okay. Okay. Thank you for confirming. Yeah. All right. So Priya, we can start. So those who have just joined, I'll just repeat. So today will be the concluding class that Priya will be taking. In today's class, we will revise the things that has been taught so far. So if you guys have any doubts, please clarify it today. So today will be Priya's last class. Thank you, everyone. Priya, you can start.
Yeah, thanks, Shaina. So what we'll do is we'll start from the beginning. So I think we have already completed 8 weeks, right? So we'll go through all the content that we have, all the content and all the topics that we have covered in the last 8 weeks. So if you guys have any questions in between, like when we cover those topics, like right now when we'll be revising it, if you guys have any questions that you wanna ask, then you can like stop me in between and ask it. I'll quickly share my screen. Okay, I have just put the 8th and 7th week PPT. I think on the 7th week there was only one lecture, right? And in the 8th week there were three sessions. So all the four of them, whatever we have covered in the four sessions, that has been put as week 8 content. I think that will be communicated to you guys. Yeah, I've just put it. So I could not put it in the last week, so I've just put it. So I think that the PPT will reach you guys. Okay, so let's get started. So we'll be starting from the very beginning of our first session. So if you remember, the first session was basically before starting Python. We had we discussed about what is programming. So all those things we'll be repeating right now. Yeah, so basically we initially, right, at the beginning we saw why is programming even required? Why do we require to learn this new language Python? So one reason was that like we humans understand one particular language, in the same way computers also understand only certain specific languages. So to be more precise, computers can, like your computer like the hardware present in your computer can only understand zeros and ones, which is binary, right? So you have to communicate your requirements, whatever work you want to get done from your computer, in such a way that the computer can translate it into zeros and ones, and the hardware of the computer will understand that language. So that is why certain programming languages have been written, so that we programmers can use those languages and we can tell computer what is expected of it to do. Okay, so just as Python has been written by like developer only, some developer who probably understands that hardware works in such a specific way, and how can I make it easier for other developers to interact with the hardware. So it's a way in which programmers can input instructions into the device, into the computer device. So like either the computer or mobile phone, you can write a code for your mobile phone as well, right? That's how apps are. Even the apps that you use on your phone, somebody has written the code for those apps, and you're just an user using that application. So you're on the user side and someone else has written the code for that application. So even that code has been written in a certain language, so that the device, the actual hardware device, can perform functions that the user requires of it. So programming languages basically are an interface between the user, the developer or the end user, and the hardware of the system. It is what connects the system with us. Okay. So Python is one of the programming languages, and in general, programming languages are used to instruct computer to perform various tasks. So then we saw algorithms. So when we are writing any code, okay, so we need to understand what is to be done. Like even when you are instructing someone to do some task, you will go about saying, okay, this is what you have to do, this is step one, what you have to do, step two, what you have to do, step three, what you have to do. Similarly, when you are instructing a computer, at that point also you will have to give certain steps to the computer, right? If you want it to perform certain function, some task you need the computer to perform, so you'll have to give it specific instructions of how to perform that task. This is just like giving a recipe to someone who's basically cooking for the first time. So if you want to cook a grilled sandwich, you'll have to follow a certain step written in a book or some YouTube video you will watch, in which like they'll tell you accordingly. Okay, first you take the bread and apply butter. That is the first step. Then you put on tomatoes on it. That would be the second step. Something like that. So basically, an algorithm is like a recipe. Okay. So if you're writing a code, you have a specific purpose to in order to write the code. Like if you want to create a game or a calculator, as we saw, right? So when we are creating a calculator, so that code when we wrote, so at that point we had a certain algorithm, right? We had to first take inputs from the user. That was our first step. Then we had to find out what operation does the user wants to perform. So that was our second step that we wanted the computer to perform. So first, the first step of this recipe was to take inputs from the user. The second step of the recipe was to find out what is it that the user wants to do, what operation does the user wants to do, and third one was perform that operation, and fourth one was to give the output to the user. So this was an algorithm that we followed while writing a calculator code. So similarly, whenever you are trying to write a very complicated or even a simple code, the first thing that you should think about is algorithm. Okay, first get the algorithm in your mind. Whenever you have a question present in front of you, like if you have a question saying write a program to I mean, write a program for a store operator or something like that. Write a program for the cashier at the ice cream parlor, the one that we saw. So in that case, first you'll have to first find out what is the inputs that you will be getting, that you'll be working with. What is the output that you will be needed, that you require to give to the user. So in case of an ice cream parlor cashier, what would be the input? The input would be what all items have you bought, what all ice cream flavors have you bought from the ice cream parlor. So that would be your input. You will do some processing on it, and the output would be how much is the user expected to pay. Okay. Then you have to look at who is going to use your code. So in this case, the cashier is going to use your code, right? So from the cashier's perspective, you have to understand what is it that is required, what is it that you will be outputting to this to the cashier. So in this case, in the case of ice cream parlor cashier, you're inputting your code is expected to get inputs of what all ice creams the user have bought, and you will have to give an output of how much is the user expected to pay. So you have inputs, you have outputs, and then what is supposed to be performed on this input, that would be your algorithm. That would be like, okay, now multiply each flavor with the cost of that flavor and add those the final costs. So all these things will come into your algorithm, which you have to keep in mind before actually starting to write a code. So this would be the first step, to understand the problem, to get into the algorithm, to think about in a more algorithmic way rather than directly thinking of it in a like code oriented manner. First find out what you are supposed to do and then start writing a code. So like for beginners, right, usually visualizing the algorithmic process is a bit difficult, because obviously it's like whenever you're starting fresh, you don't have much of experience, and in those cases it becomes a little bit tough to think about, to visualize things. So it's always better to put down these things in paper so that you'll get better idea about it. So similarly for algorithms, you have two ways in which you can visualize algorithm on a paper instead of just keeping it in your mind. So you can either put down a flow chart, as is given here. So this is calculating a max of two numbers, right? So like if you ever give like a proper computer science examination, then these things will come in the question and answers. But usually while coding, no one's going to ask you if you had written an algorithm. Probably while job interviews, you might get a question wherein the interviewer asks you, okay, can you just put it down on paper? What are you thinking? What is the algorithm that you have used? But in the final, like when you are actually working on something, so the algorithms are just for your own reference and they won't be of much importance. But like putting the algorithm on paper would be for more of your convenience, and not because it's going to be presented to the end user. Obviously your code would be presented to your code will work in front of the end user, but this is good in order to understand your own thought process so that you can make some tweaks here and there in your logic. Like obviously the first thing that comes to your mind might not be the right logic, right? So when you put it down on paper in terms of algorithm, you can tweak it around here and there and get to the right logic. So this is one of the flowcharts. So the basic notations of flowchart, now that we know what if else is, what conditions are, we can kind of go into like the basic notations of flowchart. So again, this is more of like a convention that people follow in order to write their algorithms as a flowchart. So here you see the ovals, right? The start and end ovals. So these are basically the start and end of your algorithm. They're always represented as ovals. Then you have inputs and outputs. So here you can see read AB. So read AB is an input, and both display B is larger number and display A is the larger number. Both of them are outputs. So here you can see all the inputs and outputs are presented in a parallelogram, right? So that is the convention. You start and end with an oval. And if you have any inputs and outputs in your algorithm, then that will be presented as a parallelogram. And here in between, if you see, this is a conditional statement, right? So you're reading A and B, and then you're putting an if condition. If A is greater than B, then if it's yes, the answer is yes, that is the answer is true. Then you print A is the larger number. No, which means the answer is false. In that you put display B is the larger number. So wherever we have decisions to make, in that point we'll be using a rhombus, a diamond, right? A diamond shape, this diamond shape. So here you have two arrows from this diamond shape, right? You have a yes and you have a no. So whenever you are putting a condition in your algorithm, make sure that you always have yes and no, both of these arrows, which means you have to take into consideration what is to be done if the condition is true and what is to be done if the condition is false. Both of these conditions have to be, both of these outcomes have to be taken care of whenever you're using any conditions. And the same, if you don't want to put it in terms of a chart, you can also use a pseudocode. So pseudocode is nothing but a basic English language. Like instead of writing the code, you're basically writing your logic in English language so as for you to like clear your thoughts. So yeah, usually like in the interviews, they won't ask you to write a flow chart. They will basically mostly try to get the pseudo code from you, even if you don't understand how to write it in terms of code at that point. So if you understand how to write pseudo code, like these are basic things, like you just have to put step 1, step 2, step 3. And then you should always start with a start. Step 1 would be start and last step would be stop. So yeah, this is the most simplest way in which you can put down your algorithm. You just have to divide your algorithm in steps and you have to write step 1. What is your step 1? Step 2, step 3. So here you can see step 1 is start. Step 2 is read A, B. And step 3 is if A is greater than B, then do this or else do that. So our a condition, right? That is step 3. That is what is supposed to be done with the inputs that the code is getting. And once you displayed the results, then you can stop the code. So this is pseudocode. So again, we saw, right, why programming languages. That is because it is like a communication link between the hardware and software. This is how you interact, how you as a developer will be able to, you'll be able to manipulate the computer system. You'll be able to make it work according to your, whatever is your work that you want to get it done. This is a set of instructions through which humans can communicate to machines. Machines only understand zeros and ones. So internally, machines will only understand zeros and ones. But whatever you are writing in your Python IDE or like in the environment, right? In the Python environment or in the PyDroid, for example, any editor, any Python editor, whatever code you are writing and you're running it, so that will get compiled such that it will be able to modify the underlying zeros and ones present in the machine. So by now we have seen certain programming errors as well. So programming errors is also very generic. So it's not just limited to Python, but these would be the errors that you might face in while using any of the programming languages. So first is syntax error. So whenever every language has its own syntax. Even the spoken languages, even when we speak certain languages, those languages have certain grammatical rules like that we have to follow too. Okay, in case we don't follow those rules, sometimes it does work. Like sometimes people don't understand very English very well, so they are not able to speak English very well, right? So but then the other person might be able to understand it using the context. But in case of programming languages, you have to be very specific. You have to like adhere to the grammatical rules of that programming language. You cannot make even small mistake, because compiler will not be able to interpret what you are trying to say based on context. Compiler will go according to whatever is the rules set in the like a compiler basically will have some rules, right? So if it's a Python compiler that is present in your PyDroid applications, when you download the PyDroid application, you'll get this Python compiler inbuilt in it. So the Python compiler present, it has certain rules in it, okay? And whenever you're writing a code, whenever you're trying to run the code, the compiler will run like on your code and will check if your code is compliant with these rules present in Python. If it's not compliant, then it will throw a syntax error. So for example, if the print statement is missing a parenthesis, in that case it will throw a syntax error. Or if like just as we saw, right, if you have a function with one parameter but you are trying to call the function without adding any argument, so that is also a syntax error. So these are some grammatical rules, and that's why that is one of the reasons why we learn programming languages, right? Because if you so now that we have learned if else loop, for loops and while loops, so most of the programming languages have the same concept. If you try to learn C++ or C, even those languages will have if else and for loop and while loop. So why do we specifically learn different languages? Because we want to understand the grammatical rules of those languages, so that it will be easier for us to write code in those languages. So that was syntax errors. And syntax errors are usually like whenever you try to run the code, syntax errors will be very much visible, because if you're running a code and something fails, if you have a syntax error, then compiler will directly tell you, okay, this is not the right syntax, and you can't go like you can't move ahead. That code won't run. It will stop at the compilation time. Okay. So now that we know what compile is, so understand that whenever you are running your code, there are two phases. It runs in two phases. One is compilation time and one is run time. Okay. So when is compilation time? When you click on the run button, or when you call your Python file from the terminal, at that point, first the compilation time will run. That means the compiler will run and convert your whole code into some understandable intermediate code. Okay, and this understandable code will then run. Okay, so basically all you have to understand is when you're running your code, there will be two phases. One is the compile time and second is run time. Okay, so when the compiler is trying to trying to validate your code, the first point would be the compiler tries to validate your code. Is your code right or wrong? At that point, if you get any syntax error, which means the compiler has found that syntax error in your code. Okay, if the compiler finds any syntax error, it will throw an error and it will stop executing. That's it. It won't get run. Your code won't go into the runtime only if it has any syntactical error. It will fail at compile time itself. Okay, and if you don't have any syntactical errors, which means compiler has validated your code, that your code is proper, everything is fine, there are no grammatical errors present in your code, then your code will start running. Okay, so if so this is actually very small split second. The compilation does not take much time, so that's why when you click on the run button, you directly get the prompt. Or if you are taking inputs, you will directly get asked for giving inputs to the code. But internally, there is this compile time which comes before your code actually begins running, and in compile time your code gets converted, code gets validated basically. Okay, so syntax error occur in the compile time itself. So if your code has any syntax errors, it won't go into the runtime and your code won't run at all. Before that only you will get an error message saying there's some syntax error. The second is logical error. The logical error is a bit difficult to find because it's not something that can be detected by compilers. So one of the examples that I think we had discussed this before itself. So if you want to add two numbers, but by mistake, if you have given a multiplication sign in between them, then that is not something that the compiler can detect for you, because addition and multiplication, both of them are like valid inputs, valid syntax, valid grammatical definitions in Python. So if you are using a multiplication instead of addition, that is what you have to detect by yourself. No, compiler is not going to detect for you. And that would be a logical error because you wanted to do something, but you have written a code that does something else. Okay, that's the basic definition of logical error. You want to do something, you want to get some task done, but your code is doing something else. Okay, it's not failing, but it's just giving you a wrong output. That means something is wrong in the code. There is some form of error in your logic. So this is difficult to find the source of error, as it's not caught by compilers or interpreters. Then the third is runtime error. So in runtime error, it's not a syntax error and it's not even a logical error. So some of the cases of runtime error are, so why is it called runtime error? Because your code has already gone through the compile time phase. It has successfully passed the compile time phase and it's going into the runtime now, which means the compiler has validated your code and now it has started running. And while it is running, something happens that makes the code stop. Okay, so one of the examples would be if you're taking an input from the user and if you're dividing a number by that input. So in this case, if the number turns out to be zero, if the number provided by user turns out to be zero, then that would be a runtime error because you cannot divide any number by zero, right? So again, in logical errors, you don't get the code does not stop in between. You'll just get some wrong output and you will have to find out on your own what the mistake was. But in runtime error, your code will start running, but in between, something happens that will make the code stop execution and throw an error. Okay, so that is runtime error. So you remember last time when we saw that try catch, at that point we were trying to raise exceptions, right, in Python. So when you're raising an exception, so that exception will be raised as a runtime exception, which means like when your code starts running after, suppose if you just go and show you an example. Okay, so let's say so inputting a number by the user. Now what I'm doing is if the number is greater than 3, then you raise an exception, something like that. Okay, so this is actually a right code. I mean, like syntactically, this code is totally fine. So when I hit the run button, the compilation is done. The compilation is successful. That's why I'm getting a prompt called input a number, right? So if I give 4, then and this runs and it throws an error. So this is also a runtime exception. This is an example of runtime exception because while running the code, there was some error which made the code stop execution. So this is an example of runtime exception, and this raise keyword that we had seen last time, this is how you generate a runtime exception by using raise. So even like there are some cases where you don't even need to raise it, like the example we saw, right? I mean, we talked about, right? When you're dividing a number by any input given by the user. Now, if the input is 0, then in that case, you cannot divide a number by 0. That is the basic rule in Python, which gets violated when you try to divide 10 by 0 at line number 4. So in this case, you don't have to specifically raise exception. Python will internally raise an exception for you. So let's see if I give 0. So it has thrown in 0 division error, right? So this exception, this runtime error has been thrown. So this was about programming error, then Pydroid 3. Okay, so Python comes in two different versions. So there's a Python 2 and Python 3, but all the programming that we have done was in Python 3. It was not in Python 2. Python 2 is actually, it was being used some years ago, but right now I think most of the things have shifted to Python 3. So like ideally you should be using Python 3 so that you can use that, like in case Python 2 gets deprecated. So deprecated means all support for that language is gone, which means you won't easily find any compilers that will like compile your Python 2 code. Okay, so that's called deprecated, which means you can no longer use it. There's no more support for it. Support as in you need compilers in order to run the code, right? So if you don't have compiler, then you won't be able to run your code. So like all these, it becomes difficult to run a code of a language that has been deprecated because there's no one who might be able to help you in running those code. So that's why Python 3 is what is currently being used, and Python 2 is a kind of deprecated. So if you're trying to write any code, you should ensure that it's in Python 3, or like that is dependent on what you're downloading. I think with Pydroid, you get both Python 2 and Python 3. So we did not have to care about what version of Python we were using. There is small syntactical differences, but we have done the whole coding, I mean, the whole Python sessions were done in Python 3. So you don't have to worry about 2 at all. So again, it's a high level language. High level, which means more towards the user than towards the system, right? So the compute, like if a language is something that the computers understand easily, which is like zeros and ones is machine language, which is it's called machine level language. But if there is something, some abstract languages that the computer can understand easily, but the user will not be able to understand. So I think that okay, let me just go to the Google. So, okay. So from here you can see it's from low to high, right? So machine code is the lowest level of language. So why is it low? Because that is something that computers can understand very easily, but it's hard for the user to be able to write in that code. Okay, so something that is very much understandable to the computer is it comes into low level languages, and something that humans can understand very well comes into higher level languages, right? So after machine code you have assembly language. Okay, so all this is actually very like an extra knowledge kind of thing. So like here you can see from lower to higher level, right? So Python is the higher level language. That is because it is more understandable to the user, and probably in order to convert Python into machine language, there is some internal steps happening, and those are very complex. Okay, some complex like background processes are happening that will convert your Python language into the language that machines will understand, which is zeros and ones. So that's why it's one of the examples of high level language. You can write a Python code and make it run on any of the platforms. So like if you're working on laptop, you can make it work on Mac, Linux, Windows. And now if you're working on this mobile phones, then even Android and iOS can also work. And it's an open source. So open source, which means like whatever code is present, like if you want to actually see how Python was created, or if you want to contribute more towards this Python language, then you can go and check the source code of Python as well. Okay, source code as in like these rules that we are talking about, right? There are some set of grammatical rules. So all these things are readily available on the internet. If you go and check Python source code, then you will be able to find out how exactly is Python written as a language. So then we have applications of Python. You actually use Python in order to create web applications for writing backend logic for the web applications, not the pages that we see on the internet. But if you want to, like those pages will be like connected to a database or something, right? In the backend. So whatever happens in the backend that you can code using Python language. You can write softwares using Python language, and also it's used for complex mathematics and handling huge amounts of data. And it's, I mean, the reason why Python has become so popular these days is because its syntax is very much similar to English, so it's easier to understand even if you don't come from a computer science background, if you don't have much knowledge about the internal workings of a computer or how to code a computer. Even in that case, you will be able to use Python easily. That's because of its simple syntax. If you look at other coding languages like C or C++, they have a bit more complicated syntactical structure as compared to Python. So this is hello world example. So yeah, so variables are a place where you store data. So example, if you want to, if you have like a pen or something, okay, which you want to use every now and then, so you will keep that pen in some pouch, right, or some compass box or something like that to store it. So similarly, if you have a data, okay, that you want to use multiple times at your in your code, then you can put this data into a container, which would be the variable. Okay, and the variable will have a name, right? So you can address this name every time, and you can use that variable at every point in your code. Created when value is given to it. So in Python, if you just give a value to the variable, which means if I say num is equal to 10, at this point I'm assigning a value to this variable, right? At this point, there will be some memory stored for this variable in the background. Okay, so whenever you are associating a value to a variable, at that point that variable gets created in the system, which means memory will be allocated for this variable. Somewhere this has to be stored, right? This variable has to be stored somewhere. So that somewhere is created, that somewhere place is created when you assign a value to it. No type information required with variables. So till now it would be very clear that we don't have to specifically say that this variable is going to hold an integer or is going to hold a string. We can directly assign it value, and that's how Python will understand, okay, this variable is right now holding a particular value. So right now, so we can do that. So see, like when I assign 10 to this num variable, so let's check the type of this num variable. So you can see that is an integer. And in Python, you can reassign variables, which means the same variable name I'm going to give for another variable. Okay, so like if I say num is equal to apple at this point, so this earlier variable gets lost. Okay, what I mean by lost is now after line number 4, wherever I use num as a num variable, wherever I use the word num, at that point I'm going to get apple as the value, not 10. So this thing has got lost because I have reassigned num variable to another like another value. So now the same num variable, after assigning apple string to it, if I try to run it, it says string, right? So the same variable got reassigned, and we did not have to specifically say that, okay, num will right now hold an integer, num will right now hold a string. Whatever value you provide the variable with, the variable will get a type of that value. So in this case, you are providing an integer to the num variable, so it took the type of num. And when you reassign the same variable with a string value, at that point it took the type of string. Variables can change type after they have been set. So this is what we just saw. First, it was an integer, and when I reassigned the same variable with a different value, with a value of a different data type, so it took the type of that second data type. So again, there are some rules which you have to see while you create variable names. So usually this is like a standard thing. You always try to create the variable names which are more short but descriptive, which means your variable should be like, from the name itself, you should come to know what is the task of that variable. So if you have a variable that stores the addition of two values, then you can make it something like rad, which is like result of addition, something like that. Something, I mean, that you can do it like it depends on you. What is it that you want to give the variable name? But it should be such that when you return back to the code, so for example, if you have written like a 10,000 or suppose say even 1,000 lines of code, and then you come back to that code about a month later, you should be able to understand what were you thinking at that point. Okay, if you want to continue the code. Okay, so at that time, you should be able to understand what each variable was. I mean, what is the significance of each variable, so that you can find out using the variable name itself. You have to name the variables in such a way. You cannot start with a number, so you cannot start a variable name with a number. Only contains alphabets, numericals, and underscore, and case sensitive. So case sensitive, which means capital and small letters are different. So here are some of the legal variable names. So as we can see, like these contain only numericals, alphabets, and underscore. And alphabets you can use both capitalized or small letters. Some of the illegal names are here. So we cannot start a variable name with a number. That's why the first variable name is illegal. The second one has a hyphen in between, so hyphen is not allowed. In special characters, only underscore is allowed in Python. No other special characters are allowed. So the second variable name would also be illegal. And the third has a space. So space is also not allowed. So that is also illegal. So next, data types. So by now, I think we have covered most of the data types, right? Except for set, I think all else, everything else is covered. Set is like to give you like a basic idea. Set is it's just like a list, okay, but it has only distinct values. Okay, which means if I have a list which contains 1, 1, 2, 3. Let me try this. I'm not sure of it, but let me just try it. If I convert it into a set, then it should have only 1, 2, 3. So all the repeated values should get lost. Okay. Yeah, so okay, fine. So set is also another data type. But it's just like any other sequential data type. But the difference is that in set you have only distinct values. Set does not hold duplicate values. So if you want to find out, so if I have this very long list of 1, 2, and 3s, okay, so I just have 1, 2, and 3, but all of them are repeated more than once, right? But if I want to find out how many distinct values are present, so that you can convert a list into a set and you can check the result would only be the distinct values. So that's the difference between any other sequential data type and a set, is that set will only hold distinct values. Okay, so let's start from the beginning. Numeric, for numeric, you have integer, you have float, and you have complex number. So complex number is the one which has like a complex part and a real part and all. So that also you can use using Python. We have seen integer and float. Integer is basic signed and unsigned integers, which means negative and positive integers and zero, whole numbers. And the second is float, right? Float is a decimal pointed number, any number which has a decimal point. Then we saw the sequential data types. So in sequential data types, we saw strings. So strings are used to represent like words and sentences, right? So that is what strings are used to represent. And you have a list which can hold multiple items. So this list can hold repeated items as well. And those items can be of any data type. There's no requirement that like a list can only contain integers or floats. You can contain elements of multiple data types in one list as well. And the next is tuple. So tuple is kind of same as list. It's just that list is mutable and tuple is immutable. That means once you have created a list, you cannot modify a list. Okay, you cannot delete any items of the list. Like if you try to delete or change any of the element of the list, so that will throw an error. Okay, you can add one more element to the list, but you cannot like modify a previous element in the list. Sorry, you can modify a previous element in the list. That's why it's mutable, which means you can change it. And for tuple, you cannot do those things. Okay, you cannot change an element once you have put it inside the tuple. So that's why it's called an immutable. And same way, strings are also immutable, which means once a string is created, you cannot change any specific character present in the string. Okay, if you want to change any specific character, then you'll have to create a separate string altogether. Once the string is created, you cannot change any of the elements present in the list in the string. You can add more elements to it, but you cannot remove or you cannot modify any of the previous characters present in the list. So that is done. Then we had Boolean. Boolean is a true or false. These are the two values that this data type has. Boolean data type has. You can have either a value of true or a value of false, and it's mostly used in case when we are trying to validate a condition, right? So if we have two numbers, so if A is greater than B, so whenever we have such a relational operator, right, like greater than, less than, greater than, equal to, equal to, equal to, so all these relational operators will give you an answer in Boolean. Okay, because you are trying to compare two things. So in case of relational operators, if you notice, we are trying to compare two things, right? We are trying to compare if a number is greater than the other, or it's less than the other, or it's equal to the other one. So all these things are comparisons, and every comparison has a true or false value, right? If this is greater than this, okay, so you're asking, is this greater than this? So answer would be yes, or answer would be no. So in all those cases, you use a Boolean data type value. Then you have a dictionary. So dictionary has a key value pair in it. So even a dictionary can contain multiple elements, but it has a key value pair inside of it instead of just a simple element. So uh, whenever you query a dictionary, or whenever you ask a dictionary using a key, dictionary will present to you with a value. That means you ask you like instead of accessing elements of the dictionary by using the index, you use a key present in the dictionary to access the value present in the dictionary. So this was about data types. Okay. Okay, so one more thing, the variables in Python. I mean, Python is a loosely typed language. So why is a loosely typed language? Because when we create a variable, we don't have to specify what type of data will the variable hold, right? So if you like this, if you can see, we are not specifying that peanut butter is going to hold the value of 5. You are directly assigning it 5. So basically, peanut butter variable can hold any type of data. You don't have to specifically say, okay, this is the data type of like this particular variable. So that's why it's called a loosely typed language. But this first example of strongly typed language is of C++. So in C++ language, along with the variable, you have to provide the data type as well. Okay, and this variable can only hold a value of a particular data type. So that's why it's called strongly typed language. So we won't be dealing with strongly typed language. We'll be dealing with loosely typed language only. So the meaning of loosely typed is you don't have to specify a data type along with the variable name. So this was the first week's PPT. Let's go back. Any questions still here?
No, ma'am.
Okay. Okay, let's see this. So blocks in Python. So we discussed that a block is a group of sentences that have a specific purpose. So like a function is a block in Python. If condition, whatever you're writing inside, if else elif is are blocks in Python. Then for loop is block in Python, while loop is a block in Python, and even last time when we tried a try, except, and finally, right? So that those are also blocks in Python. Okay, so like if this piece of Python code is executed as a unit. Okay, what this means is when a function is called, so we said, right, a function is a block of code in Python. So whenever a function is called by the name, then the whole whatever is present inside this function will get executed, right? The like I mean whatever, if you have 4 lines inside of a function, so all the 4 lines will get executed. So when the function gets called, everything that is present inside this code block will get executed. That's why it's called as it gets executed as a single unit, which means either it will execute or it won't execute. Okay, so if you don't call the function by its name, then nothing will get executed. But if you do call a function by its name, then everything present inside the function will get executed. Similarly, if you have an if-else condition, so if your if-else condition turns out to be true, if the if condition, whatever condition you're placing next to the if if clause, if it turns out to be true, then everything present inside the if block will get executed. If the condition is not true, then everything present inside the else block will get executed. So, like the pieces of Python program that are present in your blocks of code get executed as a unit. Okay, as in either it will get executed completely or it won't get executed at all. You can call it more than once. So I think this applies more of to the functions. So functions you can call it more than once, right? So in that case, can invoke other code blocks. So like this can be an example of nested loops and all. So like since one, I mean, considering function, if you take function as one code block, so you can have a for loop inside of a function. You can have an if else loop inside of a if else block inside of a function, right? So which means here in this case, if else is also a code block and a function is also a code block, right? So when you're writing an if else inside of a function, which means one code block inside the other. So you can have multiple such nested code blocks within one another. Can invoke other code blocks. This can also mean that one function can invoke another function, right? So there are two functions, both of them are code blocks. Then in this case, you can call one function from another function as well. Indentation is used to denote blocks. So I think by now it would be clear that whenever we are writing any if-else block or a loop or a function, the first is the defining statement, right? So in case of if, you have if the condition, this would be your defining statement, and whenever you have a colon, that is the start of the block, no matter what. Okay. So in case of like if-else, you have this colon. Okay, else again a colon, which means else is a separate block, right? Similarly, if you have a function, so in this case function will always have parenthesis, that is how a def keyword and a parenthesis, and again you will have a colon to end with. So that is a signature of how to start a block. Okay, and similarly with try except, so you have a try clause and then you have except. So again colon and whatever logic you want to write inside. So whatever lines are present inside these code blocks, right, which will replace the pass keyword. So all of this would be indented at a certain level, right? So it will be indented at one level ahead of what the defining statement indentation is. So if this defining statement, this is the definition, right? This is the definition of if code block. So if that is at indentation numbers level 0, then whatever code statements are present inside of this block would be presented indentation level 1. Okay, again else is a different code block, so it has an indentation level of 0, and whatever uh, like the code lines that are a part of this code block will be present at indentation level 1. So they're indented, like indentation is used to denote a code block. Similarly, if you have if code block inside of a function, so in this case, I just pass some value from this. So here if was at indentation level 1 because that is present inside the function. So this is an example of a code block inside a code block. You have one code block which is a function inside of which I have another code block which is an if code block. So again I have this colon, right, to denote my second code block. And like whatever statements are present inside the if condition, right? So those will be at indentation level 2, right? That is because my first code block is at indentation level 0. The nested code block, which means the if condition which is present inside the function, will be at indentation level 1 to denote that this if condition is a part of the function. Okay, and in order to denote that this print num line is a part of this if statement, you have to put it at a +1 indentation level from the if statement declaration. So if statement is at indentation level 1, then this print statement will be at indentation level 2. So this is how you identify what are the code lines present inside a particular code block in Python. Yeah, again, all statements with the same indentation level form one block. If blocks have to be nested, indent further. So this is cool. So scope of variables. So we have two scopes for variables. Like you can either have a local scope or a global scope. So which means local scope right now we can consider it as any variable that is created inside a code block. Right? If there is any variable which is created inside of a code block, then you can use it inside of that code block itself. You cannot use it anywhere outside of this code block, which means it has a local scope inside of the code block. Okay. Again, if you have any code block like a function, it's an example, a code block, we take it as a function, for example. So in this function, if I'm creating a variable inside of this function, which means the first time I'm assigning value to a variable is inside of this function. That is when a variable gets created, right? When you assign a value to it. So the first time when I assign a value to the function to the variable is inside of this function, which means it's a local. Which means that the variable has a local scope because its scope is only limited to the function. It cannot be used outside of this function. So that is one type of scope, local scope. And if you create a variable outside all the code blocks, that is outside all functions and all if else conditions and all try catch conditions, try except conditions. So in this case, the variable will have a global scope, which means it can be used inside all of the code blocks. So defines visibility of a name within a block. A variable is only available from inside the region it is created. So this is called a scope. Okay, so so again, the variable, the scope of variables is basically where all the variable can be used. So when it is of global scope, which means it can be used anywhere inside of the file, and if it is of local scope, then it can be used only inside of that code block. So same variable names inside and outside of a function, Python will treat them as two separate variables. I think this we have seen it before. So let's say if you have one variable, one global variable like this, and inside of this function, I have another local variable called num. Okay, so this num on line number 2 and num on line number 5 will be treated differently. The num on line number 5 is a local variable, so you cannot use it outside of the function. But if I try to print num from inside this function, it won't give me 10 as the value, it will give me 50. Because first, if you first like the scope, the local scope will be checked before going on to the global scope. So if Python finds a variable of this particular name, whatever you have mentioned, in the local scope itself, so it will get that value only instead of going out in the global scope. So this is it. And if I try to print it outside of everything, like outside of this function, So outside of this function, num has only one significance, right? Num is this global variable. There is only one variable which I can access outside of the function, which is num is equal to 10, the one that has a value of 10. So when I try to print this, it will give me a value of 10. So, okay, so I have first printed the value of the global variable. Then I'm calling the function, which means whatever is the value of the local variable at that point, that will get printed. And again, I am going to print the value of this global num variable. So you can see 10, 15, 10, which means only the value that got printed inside of the function is 15. Okay, outside of the function, the num value does not get changed. It is still 10. So this num variable and the local num variable are two different variables at this point. Okay, then local versus global variables. The scope of global variables is for the entire program. So in this case, this num is equal to 10, which is a global variable. Its scope will be for the entire program. Okay, you can use this variable anywhere inside of the program, inside any of the code blocks. Scope of local variables only in the function it is defined, or instead of function, I would say only in the code block that is defined there. And global keyword is used to assign or change variables inside functions. So we saw later on that if from inside of this function, so if this num is equal to 15 is not present, okay, in this case I can access this 10 variable. So what happens is when I say print num, so first Python will try to find this num variable inside of the scope itself, and if this num variable is not present inside the scope, then it will try to search it in the global space. So even if I don't have a local num variable, when I try to print it, it will ultimately give me this global variable. Okay, we said, right, global variables can be accessed inside of code blocks, right? Only local variables cannot be accessed anywhere else. It can only be accessed in the code block that it got created in. But global variables can be accessed in any of the code blocks. So here in this case, there is a global variable num which has a value of 10, and my function is accessing this num variable. If I call this function, so yeah, it prints 10, which is the expected answer. But now if I want to modify this 10, right? If I want to modify the global value, okay, in that case, I'll have to first tell Python that it's a global variable, and then I can modify it. So in this case, I'm just going to add 10 to the global value. So let me just print out the global value outside of the function. So this would be the global value, right? Because it's outside of the function. So like, I mean, in this case, at least there is only one num variable, which is a global variable. And in order to modify it from inside of the function, I'm using the global keyword. So yeah, so the final is 20, which means my global variable got had 10 added to it from the function. So in order to modify any global variable, you will have to use the global keyword. You have to say global space keyword, the variable name, and then you can modify that variable however you like. So this was an example of like global and local variables. So here you can see there are three functions: def add nums, def sub nums, and get move. There are three functions. Okay, and s is a global variable. So you can see all these three functions can access s. Okay, but these two functions, add nums and sub nums, have their own local variables. Like in add nums, there is NA1 and NA2, which are the two local variables. So these local variables won't be accessible to any of the other functions. Okay, whereas a global variable can be accessed by any of the functions. Okay, then we saw comments. So comments are used in order to increase the readability of any code. So again, if you have written some specific code and if you are coming back to this code a very long time, I mean, after a very long time, so in order to understand your own logic, you can add in comments whenever you're writing new logic in the code so that the next time you revisit the code, you understand what is it that you had done, what were you thinking at that point. And also, if you have written some very long code and if you want to give this code to someone else so that other person should be able to understand what is the code that you have written, so in that case also comments will be very helpful. There are two different types of comments. One is single line comment and multi-line comment. So single line comment is written using a hash character. So whenever you write a hash character, everything that is written after the hash character will be like a comment. Python compiler will not process it. So when you say comment, when you like hint to Python that this line is going to be a comment or this part of the line is going to be a comment, so compiler will not check that part of the line. Okay, so like even if there is any syntax error in that part of the line, or if you want to put in some random characters as a comment, like after the hash character, which is a part of the comment, right? So in that case, compiler will won't check that part of the line. So like it basically will ignore that part of the line, that comment that you have written inside your code. So this is one way in which you can comment in Python, which is using a hash character. And second, if you want to put in more than one line of comments, then you can use a multi-line character. Instead of adding a hash character to each of the lines, you can just directly say like triple this quotes, right? Triple double quotes or single quotes. So you can use these and you can write a multi-line comment. So yeah, int and float. So integers is signed integers, which means you can like assign negative as well as positive integers in a variable in Python. So they are often called just integers or ints, are positive or negative whole numbers with no decimal point. So whole numbers means zero included, right? So you can put in negative integers, positive integers, and zero in a Python variable. And like integers are the ones which do not have any decimal point. Float is the one that has decimal point. They represent real numbers and are written with a decimal point, dividing the integer and fractional part. So the part that comes after the decimal point is the fractional part. The part that comes before it is the integer part. And again, like you can use this type function in order to get the data type of a certain variable. Okay, Python data types, you have, Boolean, you have two values, true and false. And these values are case sensitive, which means if you want to create a variable and say you put like small t instead of capital T, so this will be an error. Python won't detect it. I mean, it will detect this as a syntax error. Say name true is not defined. Okay, so it's case sensitive, which means the T and F in true and false should be capitalized. So now it came as true. Okay, so now once you know what all data types are present, you need to know what all operators can be used inside of Python. So you have four types of operators. One is arithmetic operator, which is the general one that we use, like addition, subtraction, multiplication, division. I mean, we'll see that later. So there is arithmetic, then there is comparison or relational like operators. So here we see that arithmetic operators usually give us the output of the type that operands are. So if you try to multiply two integers, then you will get an integer as an input, integer as an output. Similarly, if you try to add two integers or two floats, then you will get the value like the appropriate value. If you are adding two floats, then you will get a float as an answer. I think only division is an operator wherein if you put two integers as operands, which means if you divide two integers, you will get a float as an answer. So arithmetic operators always give like either float or integer as answers. Comparisonal operators or relational operators will give you Boolean outputs. Okay, assignment operators will again give you I mean this is an assignment, so you won't get an answer for it. right? And then you have logical operators. So let's see it one by one. So in arithmetic, you have addition, subtraction, multiplication, division. So if you use a single division sign, so it will divide the two numbers and it will return a float. If you don't want a float, if you want the like the integer value of it, then you have to use a double division sign. Then there's modulus, which will return the remainder of there's modulus which will return the remainder of division of two numbers. For example, if you say 10 modulus 3, so in this case, if you divide 10 by 3, you get 1 as a remainder, right? So the answer would be 1. Just a second. So modulus basically gives you a remainder of yeah. Yeah, so it will return the remainder, and the last one is power. So if you use a double multiplication sign, so that means a power. So like if you say 2 double, let me just put it in right. If you say 2 and followed by double multiplication sign 3, so this means 2 raised to 3. Okay, so this double multiplication is the power sign, which means raised to. So the first operator would be first operand would be raised to the second operand. Then you have relational operators. So this is basically like comparing two values, two operands. So you have greater than, less than, equal to, not equal to, greater than, equal to, or less than, equal to. So this will give you a value of Boolean. Next, you have an assignment operator. So assignment does not give you any value, but it will modify a value of certain variable. So here you can see the first is equal to. So is equal to is used when you want to save a certain value inside of a variable. So num is equal to 10, right? So saving a value of 10 into variable num. So whenever you want to save any value inside of a variable, you use is equal to sign. You're assigning that variable with a value, right? So plus is equal to is a short form for like here you can see on the right hand side. Just a second. Here you can see on the right hand side, a plus is equal to b, that is equivalent to a is equal to a plus b. So whatever is the current value of a, that will get added to b and will again be stored into a. So this is the short form for that. So similarly, you have a minus is equal to a multiplied is equal to, and a divided by is equal to, and modulus is equal to. So this is just assigning a certain value, or like updating a value of a certain variable. And the next is logical operators. So for logical operators, you have the inputs as Boolean, okay, and you also have the output as Boolean, right? So in assignment, you have inputs as either int or floats, and there will be no outputs. For relational operators, you can have the two values, like the two operands would be either float or integer, and the output would be a Boolean. And for arithmetic, your inputs would be either ints or float, and your output will also be an integer or float. Similarly, for logical operators, your inputs will be Boolean and your output will also be Boolean. Okay, so if you have two operands and both of them are true, then AND operator will give you a value of true. Similarly, if you have two operands and either of those two operands are true, then OR will give you a value of 2. And NOT is basically inverting the value of a certain variable, which means like if you use NOT with a true value, it will result into a false. And if you use NOT with a false value, it will result into true. So this is a small table that you can use for reference. So basically here we have, like if we have two operands A and B, So if those two operands, these are the combinations that we can have with the two operands of true and false, right? And here you have A and B, A or B and not A. So these are the three operators, and what would be the value of these three operators in case there is a specific configuration for your two operands. So that you can see from this table. So it's fine. Then we saw strings and accessing characters. So string is again a word. It's a data type which stores a word or a sentence, right? So you have certain alphabets and characters present inside of a string. So when you're storing a string, the string gets stored in contiguous places, like it's shown below, right? Weeks for weeks, here it's shown, right? So all these will get stored in contiguous as in side by side. They will get stored side by side. So using index which means like you can this would be the location of that particular character. You can basically get what character is present at a certain location in the string. So you have to use index in order to get that character. So okay, I think keywords we have discussed it later on as well. So let me just Okay. So strings in Python, strings can be surrounded by single or double quotations. So we can create a string either using the single quotes or the double quotes. Anything is fine. And just as we have multi-line comments, which we write using either three single quotations or three double quotations, similarly, you can create multi-line strings as well. So like whatever you're writing inside of the single quotes, three single quotes or three double quotes, that will be considered as your string. So example, if you have a string which is so this whole thing will be your string value because you're using multi-line strings. Let's check. So here you can see everything got printed accordingly. So are stored in the memory as array. So array is basically a side by side, like basically arrays means side by side. That is how they are being stored. Like just as we saw that geeks for geeks word was being stored at in boxes that were side by side, right? So similarly, the characters present in the strings are stored side by side so that you can use an index, which means like it's starting from 0 till whatever is the length of the string. You can just access the characters present at certain position using the number of that position. So Python doesn't have character data type. The characters are also internally stored as strings of length 1, which means if instead of, so we were saying that, so in this string, right, we say that T is a character, H is a character, I is a character, but Python internally does not have any concept of a character. So even if I say some value as A, which is just one character, if I try to print the type of it, it will tell me that this is also a string. So there is no concept of a character inside Python. Everything is a string. Even a one character is a string. So here you can see class is a string, which means even a one like a string of length 1, that is just one character, is also a string. So next you can access any characters using indices. So as we discussed, like you can point out the position of a certain character inside the string and you can access the character present at that position. So you can do that using the string name and square brackets, and inside of the square brackets you will specify what index like the character present at what index is that you require. So again, if you want a substring, which is like a string starting from a particular position to a different particular position, so you can use a square bracket, and inside of that you can specify the start index and the end index, and you can get whatever substring that you require. Substring is a part of a string, a small part of a string. And strings are immutable, which means once you create a string, you cannot modify any of the previous characters present in the string. Which means if I have string 1, apple, I cannot go and modify any particular character present inside of the string. Okay, this will not work. So here I'm trying to change the character present at position 2, which is the second P, right? Which is the second P. So I want to change that second P to B. So this won't be possible because strings are immutable. So it says type error, string object does not support item assignment. Okay, so this was about strings and accessing characters. So yeah, here you can see if I just have alpha is equal to C, then C will be stored at position 0. Okay, instead if I have coffee, then all the characters of coffee, of the string coffee will be stored at contiguous locations, which means C is at location 0, O is at location 1, F at 2, F at 3, E at 4, and E at 5. Okay, and then you can access any element of the string, any character present in the string. So I can access the fifth element of the string using alpha 4, right? Because it starts from 0. In order to access the fifth element, you have to use 4 index. And here again, you have like the start to the end index. So your start index is 2, and end index would be like the actual end index plus 1, which means if you say 2 to 5, the characters from index 2 to index 4 will be retrieved. So you have to pass the indexes accordingly. So then there are some operations that we can perform on strings. So first one was addition of 2 strings. Okay. The first was addition of 2 strings. So here we have 2 strings, Python and classes. So when we add those 2 strings, what happens is the classes will come at the next position to n, which means till now n was at position 5. So the C in classes will come at position 6. So that is what happens. Like they both will get joined and they will have their separate indexes then. Okay, so Python will have the same index, but classes will go after n of Python. So again, if you multiply a string, similarly, you will get like you can see here. So that after the Python, there were 2 more Pythons added, and the indexes were according to, in an order itself. So this is the string form. This is the formatters, right? So yeah, so instead of using a plus sign in order to add the variables inside of in any output string, so here you can see I want to give the addition of str1 and str2 as add. So here instead of putting plus signs everywhere, what I can use this percentage s, and I can use it wherever there is a variable that I want to put. And at the end of the sentence, you can put a percentage, and inside of the parenthesis, you can mention all the variables that you want to be put inside of the string. Okay, so this will, the order of variable is strict, which means if I have 3% s in my string, in the output string, and if I've given 3 in the parenthesis, so the first one will get mapped to the first percent s, second variable will get mapped to the second percent s, and third variable will get mapped to the third one. So similarly, you can do for integers as well. You can, instead of using percent s, you will use a percent I for integers. Okay, so next is Python lists. So Python lists stores multiple value in a single variable. That is the function of a list. When you have multiple values and you want to store it in a single variable, at that point you use a list. It can contain items of any data type. You can get the length of a string by using the len function. You can append more items to it. That means you can add more items to the existing list by using the append function. If you want to remove items from an existing list, so that you can do using the remove function. And again, the index, I mean, every element present inside a list like is stored at a specific index, and the index starts from 0. Lists are mutable, which means once you have created a list, you can change the previous elements. Okay, so which means this will give an error. So I'll just comment it out. So if I have some list like this, okay, and if I want to change any one element, any existing element of a list, yeah, so this is possible. See, the first element got changed to 4. So then we have list slicing. So just as we have substrings in case of strings, list has a concept of slicing, which means you can slice a list from a certain starting point to a certain ending point, and you can get the sublist. So here in this case, you can see the first one, that is list 2 to 6, which means you want elements from 2 to 5, right? So again, for ending element, it is plus 1. So if you want elements from 2 to 5, you have to specify the starting index is 2, but the ending index would be 5 plus 1, that is 6. So, and you can use negative index as well. So here you can see how the negative indices are placed. Like this is the way. The last element is at index 5, positive index 5, but it is also, you can use negative index of 1 as well. So you can use minus 1 instead of using 5. So that is also fine. So yeah, so here in this case, yeah, you can see, I think it's minus 4, that is where it starts. And I think this should not be minus 1. Let's just check it. So if I have a list with values 1, 2, 3, 1, 1, 1. Okay. So now if I want to access part of a list, okay, so I want to access from minus 4 to minus 1. Let's see. Okay, from minus 4 to minus 1, right? So, okay, so it got access till here. So, like minus 4, minus 3, and minus 2, right? Exactly. So, okay, so yeah, that's fine. And if we don't want to give a certain index, like if we do not, like in this case, we are not giving the ending index, right? Which means it will go till the end. Okay, it will go till whatever is the maximum, whatever is the size of the list. It will retrieve elements from the whole of the list. And similarly here in this case, the first index is not being given. That means it will start from the beginning of the list. So tuples, then you have tuples. So tuples are identical to list, but when creating a list, you use a squared brackets. But while creating a tuples, you use a parenthesis, the circular brackets. Tuples are immutable, which means once you have created a tuple, you cannot change the previous values present in the tuples. That will result into error, just as it did in case of strings. Indexing and slicing works the same way as we have seen for lists. Use tuples instead of list when you don't want data to be modified. So as we have already said, like in case of tuples, you cannot modify the existing elements present in the list. So if you want to use a list, I mean, if you want to put the data at some place from which it cannot be modified later on, so you can use a tuple in such cases. When the amount of data is too large, tuples work faster than list. So this is one more reason why you can use a tuple instead of list. Operator precedence and associativity. So like if I have just one operator present inside my expression, so that one operator will get evaluated. But if I have multiple operators present in my expression, so there should be a way in which these multiple operators will get evaluated at the end. So that is found out using operator precedence. So combination of values, variables, operators, and functions makes a valid expression. When you have more than one operators in an expression, the rules of precedence are used. Okay, so that is used according to this table. So here you can see operators written on the left hand side. So this is the way in which the operators are evaluated. So the higher in the list, the first it will get evaluated. So for example, if you have two operators which are multiplication and addition, so here you can clearly see multiplication is at a higher precedence than addition. So in an expression which has both multiplication and addition operators, multiplication will get evaluated first and then addition will get evaluated. So that is the operator precedence. Similarly for the other operators in the list as well. Okay. Now, if more than one operator is in the same group and hence has the same precedence, then associativity is used to evaluate the expression. Which means now if you have two multiplications instead of one multiplication and one addition, so how do you find out which one will get executed first? Because in this case, both multiplications are at the same precedence level, right? We have two operators which are both multiplication signs, which means both of them are at the same precedence level. So in that case, we use associativity to find out which operator will be evaluated first. Okay, so here on the right hand side, you will find out the associativity. So left to right means that whatever operand is present on, whatever operator is present on the left hand side, right, that will get evaluated first. So if you have something like 10 into 3 into 4. So in this case, 10 into 3 will get evaluated 4, and then whatever is the answer of this, which means 30, that will get evaluated, that will get multiplied by 4. So the intermediate steps would be 30 into 4 and then 120. Okay, so this power has right to left associativity, and rest all mostly have left to right associativity. So here you can see in this list as well, the second one has right to left associativity and the last one has right to left, or everything else is left to right only. So not operator and power operator both have right associativity, and all the others have left to right associativity. So yeah, these are some examples of operator precedence. So in this case, you have, sorry, this is, just a second. Yeah, this is operator precedence. So here you have an addition sign and a multiplication sign in the same expression. So as we saw, the multiplication sign is at a higher level than addition in the table. So multiplication operation will be evaluated first. Okay, you will get the answer of that multiplication operation and then the addition operation will get evaluated. And here in this case, both multiplication and division are at the same level of precedence. So in this case, associativity will be considered. So since multiplication has an left to right associativity, the expression on the left, which means 100 divided by 10, will get evaluated first, and then it will be, the result will be evaluated with the next operator. So in this case, that would be evaluated with multiplication sign later on. Okay, then we saw the conditional statements in Python. So conditional statements, okay, so till now whatever we had seen was sequential. So sequential means if you're writing 10 lines of code in your Python file, then all the 10 lines would have been executed. Okay, there was no condition anywhere, so everything would have been executed. But once you introduce conditional statements in your code, wherein you're checking a certain condition, so some part of the code may run, some part of the code may get, maybe omitted. That is, if you have an if-else condition in your code, then if the condition is true, only the if block is going to get executed, right? The else block will get omitted. And similarly, if that condition is false, then the else block will get executed and if block will get omitted. So these are conditional statements, which means the code will run only if certain condition is satisfied. Okay, so till now, all the statements we have used have been sequential. Control structure directs the order of execution of code. Okay, so in real world, this is cool. The code will be executed only if a condition is satisfied. Okay, that is the use of an if block. If is used in Python for conditional execution of a statement. So if you have if space the expression, so what if that expression is true, only then the statements will get executed, and you have to indent those statements inside of the if block. And also you can have nested if blocks. So here you can see there is an if expression and there are certain statements inside of the if block, and there is a following statement. So if the if condition is true, then all these statements will get executed and that will be followed by the following statement. But if condition is false, then it will directly go to the following statement. It will not execute anything that is present inside of the if block. Else and elif clauses. So if clause comes with you can use it along with elif and else clause. It's optional. If you just want to use if block, that is also totally fine. But you cannot have else and elif clauses without using an if block. You cannot directly use an else block without first having an if block. Because if has a condition, right? So you have to first check a condition. So in order to check a condition, you need to have the if block. So sometimes you want to execute a block of code if the if condition is evaluated to false. Okay, so if the if condition is evaluated to false, then either you can execute the else block or you can check for another condition. Okay, so if in cases if you have only two options, like while checking if a number is even or odd, just a second. Just a second. Yeah. So if you sometimes if you have a condition which has only two outcomes, like if you're checking a number, if that number is even or odd. So if that number is, if your condition is to check if a number is even, so that has only two options, right? Either it can be even or it can be odd. So in that case, only if else blocks are enough. But if you want to check a certain, a condition which has more than one options, okay, in that case you can use elif clauses. So like if this is so for example, if I want to check if a number is either 0 or it's greater than 1 or it's less than 1, so in that case, if I can have a number, some number, okay, so I can say if num is greater than 0, okay, that would be my first condition. If it is greater than 0, now there can be two options, right? If it's not greater than 0, then either it can be equal to 0 or it can be less than 0. So I still have two more options. Okay, so I can use another elif statement to check if that number is less than 0. Okay, now in this case, if it's not even less than 0, which means we have already checked two conditions. If the number is not greater than 0 or if the number is not less than 0, that means I can conclude that the number would be equal to 0, right? So then I don't have to check a condition, I can directly say else. Okay, so in this case, I had three options, right? I had the num field, whatever condition I was checking, I could check it in three ways. I can check if the number is greater than zero, less than zero, or it is equal to zero. So I used an elif statement in between. So similarly, if I want to check if a number is even or odd, I can say num mod 2 is equal to 0. So this is a way to check if a number is even, right? So if a number is when divided by 2 does not have a remainder, which means the number is even. So now if this condition is false, I can conclude easily that the number would be odd. Okay, there is no any intermediate state. It's either even or odd. So if I'm checking a condition whether the number is even and this condition turns out to be false, that means the number is odd. So I can assume it easily. Right? So like these are the two ways in which if, elif and else can be used. So if there are multiple conditions, elif can be used. If one of the conditions is true, others will get ignored. Which means if the first one, right, if you have multiple elif conditions, you can have any number of elif conditions. If you have all three, if, elif, and else, you can only have one if condition. You can have only one else condition, but the number of elif in between can be any. Okay, you can have multiple elif conditions in between. So now, if suppose the if this first if block comes out to be true and it gets executed. So after the if block is executed, the rest of the control statement will be like it will be passed. Okay, it won't the Python won't check elif statement again. Only one of these conditions can be true. So if the first condition is true, Python won't go and check all the rest of the condition. It will directly come out of the control structure. Yeah, so here in this case, you have more than one elif statements. So if any of these if or elif comes out to be true, then the rest of the control structure will get omitted. So you can use nested ifs as well. So here you can see I have one if statement. I mean if elif block nested inside the if statement. So if the variable is less than 200, you do something, or else you print could not find true expression. But if the variable is greater than 200, then you can further check if the number is 150 or it's 100 or it's 50 or it's less than 50. So right, you have multiple conditions that you check in case your first condition comes out to be true. So you can again see how indentation works in this case. So you have like from indentation itself, we can find out which statement is a part of which block. So that is how it should be. Indentation should be used to find out, it should be clear from the indentation which condition is a part of which block. So then we had loops in Python. So Python has two loops, for loop and while loop. Basically, all loops have the basic functionality. That is, it will run a certain part of the code again and again. The code block that you're writing inside of the loop will be run again and again. Only the way in which you use these two loops is different. Both the loops will run till a certain condition is met. So, but the way in which we define this condition differs for both the loops. So, in case of while loops, in case we don't know how many times the loop has to be run, but if we know a certain condition has to be met, like before the loop gets stopped. Okay, so in that case, we'll use a while loop because with while we use certain statement, we use some conditional statement. So here in this case, you see there is one condition saying I is less than 6. So till I is less than 6, you keep on running the loop. That is what it means, right? So along with while's clause, you use a certain expression and you evaluate the expression every time, every iteration of the loop. And when the expression turns out to be false, when the expression gives a value of false, at that point you come outside of the loop. That is when while loop is used. So execute a set of sentences until the condition is true. So whatever condition you are specifying, until that condition is not false, the loop will keep on running. Till the condition is true, it will just keep on running. indented statements required. So as any other code block, in a while loop also, once you have the defining statement, all the other code lines that are present as a part of the while loop should be at a certain indentation level. Condition should evaluate to true or false, and loop can be broken in between. So we can break a loop in between. Any loop can be broken in between using the break keyword. So this is one of the examples. So here you have this condition I is less than 6. So along with while, so till I is less than 6, the whatever the contents of the loop are, they will keep on repeating again and again. Okay, so you have these three keywords that you can use along with loops. One is break keyword. So the break keyword is used when you want to break the loop in between before the condition is satisfied in case of while loop. So if the condition is true but you still want to break that loop, so in that case you can use the break keyword directly. Yeah, it will break loops one by one, which means if you have a while inside a while, so if you have a while inside of a while some condition, okay, and there is again while some condition too. So if you have two while loops nested one inside the other, and if I say break, okay, only the immediate while loop will get broken. Okay, only the internal while loop will be broken. The outer while loop will not get broken. So one break will only break one loop. So second is continue. Continue returns the control to the beginning of the loop. So say if you have this while loop and you have some 5-6 sentences in it. Let me say statement 1, 2, statement 3. Okay, and then I'm checking some if condition, and if this if condition is true, then I'm going to say continue. Okay, and I have 2 more sentences. Okay, so what this means is when the while condition will be, when this loop will be run, supposing the condition says that on the second iteration, you will have to continue. Okay, so in the second iteration, what will happen is after the statement number 3, the control will come to the if condition, and if this if condition is true, and then Python will continue, which means the control will go back to the start of the loop, and statement 4 and 5 will be ignored for that iteration. So continue means wherever there is a continue inside of the loop, the control will go back to the start of the loop. That is what it means. And the last is pass. So pass we have been using for, like over here also we have used for a lot of number of times. So pass means that particular logic is passed for the moment. That code block is passed for the moment, which means right now nothing is happening in that code block. If you just keep it open instead of writing anything, this will give an error. In case you have not come up with any logic, if you after colon, if there is nothing, okay, no indented block, then this will give an error. So in case you want to leave it empty for the time being, you can just say pass. You can use the pass keyword. So then you have for loop. So you use for loop in case you know how many times the loop has to be iterated. Because in for loop you specify a number, right? You say, okay, for I in range 5, for example. So that means for 5 times the loop will keep on running. So in this case, when you have a specific number of times the loop needs to be run, so in that case you will use a for loop. So it is used for sequential travel, and it is called definite iteration. That is because you know how many times the loop will be run. Okay, so the loop will be iterated only a specific number of times. We can also execute statements once for each element in sequence. Yeah, so you can say for I in list. Okay, so for every element in the list, the loop will get executed. Similarly, you can say for I in string, which means for every character present inside the string, the loop will get executed. Can use break statements. You can also use continue and pass along with a for loop. So yeah. So for loop, you can use range first of all in case you know. I mean, if you know a certain number of time, like say if you want to run a loop for 10 times, you can say for I in range 10. So the loop will keep on running for 10 times. If you want to use list, string, and tuples as a condition for loop execution, so that also you can do, and you can nest one for loop inside the other. Any kind of loop can be combined. So which means you can have a while loop nested inside a for loop, or a for loop nested inside while loop, or a while inside while, or for inside for. So any nesting is possible, and you can nest it as many number of times as you want. You can also nest if else conditions inside of loops, or loops inside of if else conditions. So basically, these are all blocks, right? And you can have one block nested inside the other. So you can have any of the blocks nested inside the other. Okay, yes, this is. Okay, then we saw dictionary in Python. So dictionaries are collections, unordered. So unordered means you can't access, like just as a list, right? In a list, how you have elements that can be accessed using an index. So you know this is the order in which the elements are present inside of a list, but you cannot say what is the order of elements present inside of a dictionary. You cannot access any element using the index in a dictionary. You will have to use a key in order to access the value from the dictionary. These are changeable and indexed. So changeable means that like you can change a particular value for the key present in the dictionary. Okay, and items of dictionary can be accessed using keys. Follows key value pair. Length can be found using length. Duplicate keys are not allowed. So basically, duplicate you can put duplicate keys, but that would be of no use. Like even if you have duplicate key, the behavior will become very unpredictable. So if you have two keys with the same name, so when you try to access a value from the dictionary, what is the value that will get like retrieved, right? So that becomes an ambiguity. So avoid putting duplicate keys inside any dictionary. Keys are case sensitive, and nested dictionaries are also valid. So I think this example we have seen previously, wherein we had a value in a dictionary as another dictionary. So adding, updating, and removing items. So yeah, so adding an item. So if you just say the dictionary name, and in the square brackets, if you pass the key name and you use is equal to value. So this is how you add any element into the dictionary. You can also update any element similarly. Okay. Think for removing, yeah, dot pop is used. A dot pop method is used in order to remove any element from the dictionary. And inside of the pop, inside the parenthesis of the pop, you will have to pass what is the key that you want to remove from the dictionary. So this is the way in which you access elements of a dictionary. Like you can use a for loop in order to iterate through all the key value pairs present inside a dictionary. Keywords are certain like words that have some significance in Python. So why do we understand keywords? Why do we have this list of keywords? Because we don't want to use keywords as variables in Python. That would be like that will fail. That will give you a syntax error. Because you cannot use these keywords as a variable names in Python, because they have certain specific purpose. So we have, I think by now we must have seen most of them. So we know false, we know none, true, and elif, del, def, continue, break, all these things we have seen, right? Else, except, finally, for, if, global, or not, is, in, import. And in the last one, we have seen pass, we have seen raise, return, try, while, and with, right? So all these things we have seen till now. So global has already been taken. Okay, so I think functions would be like pretty much covered by now. We have given a lot of time for functions. So I guess we don't have time for the last PPT. So you guys can go through it, and like if there is any questions, so I mean mostly I think everything would be covered in the videos. So okay, so this is the last PPT is basically about importing modules and creating of modules, right? So you can use a Python file, a Python code as a module in some second file as well. So that we have seen in this last two sessions, last 2 weeks. So we can import modules into our code and we can reuse the code that we had written earlier. We've seen about the main code block, like if we what happens if we use if underscore underscore name is equal to main, then there are certain string functions that we went through. And then we saw error handling. So error handling can be done in two cases: exception handling, which means if there is any runtime error, like the one we saw today at the start, right? If there is any runtime error that is happening in the code, that might happen in the code, so we can handle that exception in such a way that the execution doesn't stop even if there is some error in the code. Okay, so that is done using exception handling. And assertions are basically you trying to test the code and check where the error could be in the code. So for exception handling, a Python will normally stop execution and generate an error message. This is when you're not handling any exception. But if you want to handle it, you can use a try except finally block, and you can handle any exception that can happen inside the code. So in the try block, right, you can test a part of the code, and in case there is any exception, so that can be handled by your except block. Whatever you like execute inside, whatever you're writing inside of your except block will get executed if there is any exception that occurs in the try block. And finally block is used in order to like whatever code you have inside the finally block will be executed in both the cases, if there is an exception or if there is no exception, both the cases. Okay, so that is one thing. And if the try block raises an exception, then the except block will be executed. You can define as many except blocks as you want with one try block. Okay, there'll be only one try block, but you can have as many except blocks as you want. And also there'll be one finally block. You cannot have more than one finally block. Finally block is exceptional. If you don't want to have finally block, that is fine. Okay. Else block can be used to execute code if no exceptions are raised. So along with try except, there also can be else block. So if there is no exception in the code, then the contents of the else block will get executed. And if you want to raise exceptions manually, then you can do that using the raise keyword. These are some of the standard exceptions. And last time we saw how to work with files. Yeah, we saw how does the directory system work and how do we reference a particular file, right, from one place. If you want to access a file which is present at a different location, how to do that, how to open and close files, and that is usually done either with try finally block. That is, you try to open a file inside the try block. If something goes wrong, then that is like that will be handled by the except block. And finally, no matter what happens, you will have to close that file. So inside the finally block, you will close the file. Okay, that is one thing. And so yes. Yeah, then we saw how to read and write from files. So using read lines and read line, so you can read either all the contents of the file, or you can read it line by line, or you can read a certain number of characters from the files. And you can also write it accordingly. You can write all the characters, or you can write certain number of characters or on one line. And also you can use the files in an append mode, which means like if you open a file in a write mode, then all the contents of the file will get overwritten. But if you open it in the append mode, it will just like whatever you want to write to the file will get appended to the existing content of the file. So yeah, I guess that is it. Any questions still here? Any questions from anyone? So we have roughly gone through all the content that we have covered till now. So yeah, Shaina, I guess if no one has any questions, we can close the
Yeah.
session.
Yeah, I guess someone has some question. Yeah, please go ahead.
Okay.
Was someone asking something? So, guys, this was the last session of this series with Priya. If you guys have any doubts on whatever she has taught today, or maybe you have solved some questions that she has given, or anything, please feel free to ask. Please confirm in the chat if you guys have no doubts. We will close the session. Can you guys hear me? Priya, I am audible, right?
Yeah, you're audible, Shaina.
Okay. Students, if there are no doubts, we will close the session. Okay. Thank you. Thank you so much, Priya, for the session series. It was great. It was great. I hope students have learned so much from you guys. Students have learned so much. I hope you also had a great experience teaching these kids.
Yeah, Shaina, thanks a lot. Yeah, I had a great experience. I hope everybody has understood whatever we have gone through. So yeah, that thanks a lot, guys. Thanks, Shaina, for the
Yeah, yeah.
opportunity.
Yeah, Priya. Hope to have many such sessions with you in future. Guys, so we
Yeah,
are closing the session. If anyone has any questions, one last time we can just ask. All right. I guess no one has any more questions. Thank you, students. Thank you for listening patiently throughout the session series. Thank you so much, Priya, for giving these sessions to these students. Thank you, everyone. Bye bye.
thanks. Bye.
Bye bye.